So what we're going to do is we're going to do section 4.9 resistors in series and parallel. And one of the things about when you do an electrical circuit, when you actually make something up in reality, usually it's going to be more than one resistor. So we might have a battery, remember that's the symbol, plus is the big plate, and there might be a light bulb in there which acts as a resistor, and there might be some other element in there that acts like a motor which acts as a resistor. So, or you might have a series, so these are in series, the electrons will go through the circuit, through this one, then that one, so it's a series circuit. Remember, to be in series it must go through one, then the next. Or one system, if we're dealing with lots of light bulbs, is we might have light bulbs in parallel. This way, if this light bulb blows, it's not going to affect that light bulb. In this case, if this was two light bulbs, if this one blows, there's a break in the circuit, no light. This one, if you blow one light bulb, not a problem. But each of these is going to have a resistance. So the question is, how do you add resistors in series and in parallel? And well, adding in series is actually quite easy. If you have two resistors, let's call this one R1, R2, then R total is just going to equal R1 plus R2. So in the above case, if I want to find out what the total resistance, say that's a 6 ohm resistor and that's an 8 ohm resistor, then I'd go R total equals 6 ohms plus 8 ohms, and that would give us 14 ohms. Let's do this with the example given in your notes. Let's do example 4.12. And what we have here, circuit with two resistors in series. Okay, so we've got V equals 20 volts, R1 equals 15 ohms, and R2 equals 5 ohms. So we want to know what the current, what is the current, what is our total, I and V1 cross R1 and V2 across R2. Okay, so there's a lot of things. So let's draw a circuit, let's draw our power supply. Then we're going to have two resistors. There's resistor 1, resistor 2, complete the circuit. Step 1, draw a picture. Right 2, write down what you know. We know that that's 15 volts. We'll call this one R1, and that's going to be 15 ohms. And R2 is going to be 5 ohms. Now what happens is, as the current goes around the circuit, it's going to meet resistor 1, and it's going to burn up some energy. For every amp that goes through there, it's going to, or every coulomb of charge that goes through there, it's going to burn up some energy. And then it's going to burn up some more energy over here. So two things we have to work out. We have to work out what is the total current leaving the battery, and to find out the current leaving the battery, V equals IR. Rearrange that for I is equal to V over R. But this is going to be the total resistance, because this battery only sees that total resistance. So R total equals R1 plus R2, which equals 15 ohms plus 5 ohms equals 20 ohms. So the total resistance equals 20 ohms. So the current's going to equal 20 volts over 20 ohms equals 1 amp. Now isn't that nice, a simple question? So we've got 1 amp. We've got, remember, 1 amp is 1 coulomb of charge going through there every second. So how much of that energy is being burnt up here? How much is being burnt up at R2? So what we're going to do, if I want to find out the voltage across here and here, how much voltage is being burnt across here? For R1, voltage 1 is equal to the total current going through there times the resistance of R1, which is equal to, well, we know I is 1 amp. We know the resistor is 15 ohms, and that means 15 volts, 15 joules per coulomb is being burnt up there every second. So 15 volts is burnt up there. For R2, there's two ways of doing it for R2. We can do the same thing. V is equal to I R2, which is equal to 1 amp, times 5 ohms, which is equal to 5 volts. And if we add these up, we can go 15 volts plus 20 volts. We're burning up 20 volts across here. So we've got plus 20 here, comes across, burns up 15. We've got 5 left, burns up 5 there. Got none left on that plate. Isn't that cool? So with resistors in series, it's going to burn, the current through the resistors is going to be the same for all of the resistors in the series, but the voltages are going to be different. Some's going to be burnt here, some's going to be burnt on this one. So, yeah, so the current is the same. In series, the current is the same, the voltages for each resistor are different. So then we get the question of, go back to this page. So for in series, current is the same, voltage is different for each resistor. Okay, let's try putting them in parallel. Now, when they're in parallel, we actually have to approach this problem differently. I mean, if it was the same, then we wouldn't have to teach you two different ways of doing this. In parallel, and I'm going to use the symbol here for parallel, basically, we can't just add them together. In a parallel system, some current is going to go through this one, and some current is going to go through that one. But in no case is some current going through both of them. If it's going through both of them, it's in series. So if some current goes through this one and some goes through that one, that's in parallel. And the way that we work this out is we have to take into account each bit going in parallel. So we go 1 over R total equals 1 over R1 plus 1 over R2. And, which I know seems complicated and annoying, sometimes this is written by R tot to the minus 1 equals R1 to the minus 1 plus R2 to the minus 1. I mean, that's just another way of writing that. So you cannot just add those two together. If we could just add them together, we'd do that. Some people will try and simplify that equation into that equation, and no, you cannot do it. That's why we have to have two separate equations. But let's put in some values here. Let's make this resistor here 6 ohms, and let's make this resistor 3 ohms. So R total, 1 over R total equals 1 over 6 plus 1 over 3. And if you do that, you go 1 over R total equals 1 over 2. So in this case, because there's no pluses or minuses, we can just flip those fractions. So R total equals 2 ohms. Okay, you'll notice something interesting here. 2 ohms is less than either of these resistors. So when you have two resistors in parallel, then the total resistance is going to be less than either of them. And that's actually a good cross-check to do. If this is less than that one or that one, then you've probably got the right answer. If this is bigger than one of those, then you've got the wrong answer. Okay, another thing that happens here, in parallel, so this is related to this here, for each resistor, the current is different. So some current will go through here and some current will go through there. And unless those resistors are the same size, they'll have different amounts of current going through each of them. But, because if I looked at this and took this as a single circuit, you'd see the 6 volts from there to there. If I looked at this as a single circuit, you'd see the 6 volts from there to there, or whatever the voltage is, from there to there. The voltage is the same. So, in series, the current is the same. In parallel, the current is different for each resistor. In series, the voltage is different from each resistor. In parallel, the current is the same for each resistor. And this is an important thing to actually remember. So let's actually do the problem exercise 413. For the two resistors in parallel, V equals 10 volts. R1 equals 15 ohms, R2 equals 5 ohms. So these are the same resistors. These are the same resistors that we had in this problem, but now they're going to be in parallel. So what's the question? What is R total? And what is I total, I1 and I2? So what's the current through from the battery, and how much is going through each resistor? So let's step one, draw a picture. Here's our little battery. We've got 10 volts there. Got resistor 1 here, which is going to be R1 equals 15 ohms. Down here we're going to have R2, which is equal to 5 ohms. Okay, so for both of these cases the voltage is going to be 10, because remember, when they're in parallel the voltage is the same but the currents are different. So how can we work out the total current? For total current, what we need, V equals I total, I total R total. So rearrange that. I total equals V over R total. So the first thing that we have to do is work out what the total resistance is. So 1 over R total equals 1 over 15 R1 plus 1 over R2, which is equal to 1 over R total equals 1 over 15 ohms plus 1 over 5 ohms. So R total, by rearranging, remember if you take the inverse of both sides, we can go 1 over 15 ohms plus 1 over 5 ohms, all to the minus 1, and most people stick this into their calculator as R total equals 15 to the minus 1 plus 5 to the minus 1, and they put that in brackets, all to the minus 1. So first of all, find my calculator. So I go brackets 15 to the power of minus 1, which is a button on just about all calculators. There will be a button that's to the power of minus 1, plus 5 to the power of minus 1, close the brackets and take that all to the power of minus 1 equals 3.75 ohms. So our total is equal to 3.75 ohms. Yep, and so what we'll do here, so current total is going to equal the voltage, 10 volts, over our total, 3.75 ohms, equals 10 divided by answer equals 2.667 amps. So we're shoving 2 2/2 amps through that circuit. Now remember, now if I want to find out I1 equals voltage over R1. So the voltage, remember each of these resistors are going to see 10 volts because we're in the parallel, they send the same voltage, divided by R1 is 15 ohms. So we do just stick that through the calculator, 10 divided by 15 equals 0.667 amps. And we go I2 is equal to V over R2, which is equal to 10 volts over 5 ohms, don't need a calculator for that, equals 2 amps. And if we add these up, you'll notice it's 2.000 amps plus 0.667 amps equals 2.667 amps, which is the same amperage as here. So if we draw this as a picture, we have 2.667 amps coming out of the battery. At this point, 0.667 goes down that path, and at this point 2 amps goes down that path. So strangely enough, as it comes to this intersection, some goes this way, some goes this way, but when you add those two together, it's going to equal the amount that came out of the battery. Hopefully that sounds reasonable to you. So yeah, so basically there are two ways of adding resistors together. When you're just adding resistors together, it's really easy, just R1 plus R2 when they're in series. Series is really easy. Parallel though is a more complicated system. We have to use 1 over R1, R total plus what equals 1 over R1 plus 1 over R2. And remember, these are not interchangeable. A lot of students will for some reason think that these are just interchangeable. No.